Gas metal arc welding metal transfer modes. Gary Pace, PE, CWI, Katy, Texas. Okay, learning objectives. Gas metal arc welding has 4 separate and distinct transfer modes. We've got short circuiting, globular, spray transfer, and pulse spray transfer. These are going to be our learning objectives for this module. Okay, so when we're talking about gas metal arc welding modes of transfer, we're going to talk about short circuiting, we're going to talk about globular, spray, and pulse spray. Each one of these has some significant differences from the other modes of transfer. And there's some different ways on how we get to these different modes of transfer that include, but are not limited to, wire size, the shielding gas we use, the amount of current and voltage. You know, a lot of these are variables that are going to affect what our gas metal arc welding mode of transfer is. And you're going to run across this a lot when you start getting into welding codes, because some of them are considered one process and short circuiting is considered its own process. Here's our transfer modes again, different slide, same information, maybe a little more. Gas metal arc welding transfer modes. Here's the 3 main ones, and we'll talk about pulse later on. But with short circuiting, it's usually less than about 20 volts. Out of position welding can be done, which means we can run it uphill or overhead and not have an issue. The problem is you're going to have cold lap and lack of penetration. These things can come into play, and it's going to give you issues. So this is the lowest energy of the welding transfer modes. Globular is low current density. It results in erratic arc and globules of metal that are larger than the diameter of the wire. So with this process, we don't really get to the wire never touches the base material like it does in short circuiting. Globular, there's enough electricity going through there, enough current that it breaks off melts the wire before it gets there and turns it into a globule, like a booger or something getting flicked on the wall. But that's how we do. There's enough electricity in there, but we don't usually use globular because it's kind of messy, a lot of spatter and whatnot. So generally you don't see the globular transfer mode used. Spray transfer is generally associated with higher amperages and voltage levels and occurs with argon and argon-rich shielding gases. Needs about 80% argon for spray transfer to happen. Okay, here's another slide, but this one we're just talking about current. So short circuiting is on the far left side. It's the lowest energy of the transfer modes. It's low voltage, you use small wire sizes, and it's the lowest of the energy of the transfer modes. I've said that 3 times. But it's low energy. That's why it's generally considered its own welding process. So then if I go over to the next one, I turn my amperage and wire feed speed and my voltage up a little. I'm going to transfer into globular. And globular, as you can see, has a different, the process is a little different as far as the size of the way that the liquid weld metal disassociates from the welding wire and gets deposited into the weld joint. It actually breaks up before it touches the weld base metal. And then by the time we get to spray, we turn our amperage and voltage up even more. And by the time we get here, it's just disintegrating. If you've ever seen spray arc, it just disintegrates into a spray. There's enough electricity flowing through there that it just turns the wire into droplets. And once again, this one doesn't touch the base material either. And then we get over to pulsed. Pulse spray is just going to be, you're going to move the current up and down. You're going to vary the amount of current amperage that's going into the weld puddle, and it's going to allow the weld puddle to be heated and cooled and heated and cooled. And this adds some advantages that aren't there in spray. the spray transfer mode. So, but pulse is just basically pulse spray transfer. When we're talking about gas metal arc welding short circuiting, the best way to kind of figure out that it's going on is going to be the voltage range. So if you're an engineer and you're out walking the shop, and you got questions, the voltage range is pretty much the best guide. A low voltage is one of the reasons that gas metal arc welding short circuiting does short circuit. If the shielding gas is CO2 or an argon CO2 mixture, the filler metal diameter is 1/16 diameter or less, and the voltage is 22 or less, most likely the GMAW process is in the short circuiting mode. So generally I use like 20 to 22 volts to figure out whether it's in short circuiting when I'm looking at a welding procedure. So, but anything under about, for smaller wire diameters, anything under about 20 volts is generally short circuiting mode of transfer. This slide we're looking at the transfer modes, and we're using argon shielding gas and 0.045 carbon steel wire diameter. So this would be your approximate voltages for, if you start on the far left side with the lowest one, we've got short circuiting, and it ends at about 20 volts, 20.5, somewhere in that ball game. And there's a little overlap between that and globular as we crank up our voltage. And then as we move from spray into globular, globular is going to take over in the 20-some range, and then it's going to head up to about 25 volts. And about 24, 25, we're going to start going from globular into the spray transfer mode. And then as we just crank this up and keep going, it's going to stay in a spray mode. There is no mode after that. But this is only for argon shielding gases with at least 80% argon. And I don't know if 80 is the number exactly, but it's a good round number. I've read it in various pieces of literature that it's 80%. 75% argon CO2 will not get you into spray transfer, but 80% and more will get you into spray transfer if you've got 80% or more of argon shielding gas. And this is what it looks like as we crank up the voltage. Here we're using CO2. CO2, there is no way we're going to get to spray, no matter how much we crank up that voltage. So we're going to make the transition from short circuiting into globular, and it's going to stay in globular. Carbon dioxide is not going to support trace transfer. Metal transfer is restricted to short circuiting and globular modes with 100% CO2, and anything less than about 80% argon is going to be restricted to short circuiting and the globular mode of transfer. The shielding gas really comes into play when we're talking about the transfer mode. So the effective shielding gas, I'm not going to read the whole slide. This is probably the one time I don't. But the shielding gas defines the metal transfer mode along with the welding parameters. So if you don't have argon in your shielding gas mixture of at least 80%, you're not going to be able to get into spray arc. You're going to be stuck in either globular or short arc. Argon will support spray transfer, but we need a minimum of 80% argon to support spray transfer when we're doing gas metal arc welding. Minimum of 80%. If we don't have that, we're either stuck in globular or short circuiting modes of transfer. Carbon dioxide is a gas that's often used with gas metal arc welding, but the thing to remember is it's not going to support spray transfer. Metal transfer is restricted to the short circuiting and the globular modes. Okay, with short circuiting, this is the only one where there's only transfer mode where there's multiple things going on. So if we start out over on the far right side with the 1, when the wire touches the metal, it shorts it out. This is the only transfer mode where the wire actually touches the metal. So number 2, the high current flow melts the end of the wire and a droplet is formed. So it goes down, it touches the metal, and a droplet's formed. Right then, we go to 3. The current pinches off the droplet and the arc stops for just a sliver of time. And then as the wire continues to move, the arc restarts. So you have an arc going for just a second, and then the wire touches the metal and the process continues. So there's this constant process with short-circuiting transfer mode of the wire touching and melting the base metal. So, and then this process is recognizable by its sharp buzzing or crackling sound. This is the most common method of transfer, and you need to have everything set correctly for this process to work correctly. So that's about all there is for short-circuiting transfer. In GMAW short-circuiting, the arc is short-circuited. The molten weld puddle is able to freeze in less time than when welding with other transfer modes. This allows welders using gas metal arc welding short-circuiting the ability to weld out of position and to weld thin base metals and to weld open root passes without backing and without blowing through. The major bad characteristic of GMAW short-circuiting is that the quick freezing puddle has a tendency to cold lap when not carefully deposited with the correct technique by a skilled welder. So what did I just say there? Well, this puddle freezes so quickly that unless you really know what you're doing and get it to tie in, you can have issues with cold lap and not getting your weld metal completely fused in with the base metal. And that's what we're looking at. So, but it offers you the ability to weld open roots and uphill. So there's some trade-offs to be made here if and when you're going to utilize this mode of transfer. Globular transfer occurs at relatively low operating currents and voltages, but higher than those used to obtain short-circuiting transfer. It can occur with all types of shielding gases, but with gases other than CO2, it generally occurs at current and voltage levels towards the bottom of the operating range. With CO2 shielding gas, globular transfer will take place at most operating currents and voltage levels. So the key here is it's just going to be big globules that get disassociated from the wire, and the globules are larger than the wire diameter. And if you're using CO2, carbon dioxide, the most you're never going to be able to get out of globular if you're going up. You can go down and get into short circuiting, but you can't get up into the spray transfer mode. Globular transfer is lower current density, results in erratic arc and globules of metal larger than the diameter of the wire. You get minimum penetration and excessive spatter with this transfer mode. The spray arc mode of transfer is by means of very small droplets of the fused electrode wire, none of which exceed the diameter of the wire in size. Successful spray arc transfer requires argon or an argon-rich shielding gas mixture. Carbon dioxide, once again, is not going to get you to the spray arc happy land. You just can't get there from here. And high current values. The results are high heat input, maximum penetration, and a high deposition rate. The arc force propels the droplets to the metal. Remember, with globular, you're waiting for gravity to do the work. Not here. In this instance, the arc force propels the droplets to the metal. The puddle is larger and more fluid, which means a relatively large weld puddle is a characteristic of this mode of transfer, which limits the use of this mode of transfer to flat position groove welds and flat and horizontal fillet welds. The high current density results in deeper penetration. The high current also results in high deposition rates. Process results in a hissing or whispering sound. And I didn't really touch on that too much, but each one of these processes, and we're going to touch on pulse spray transfer, all four of the gas metal arc welding processes have a completely different sound. It's hard to explain until you've been around it, but good welders can set their welding machines utilizing the sound. I've helped guys set their welding machines, and I can hear them welding, and I can tweak it because I know what it's supposed to sound like. So you're adding voltage or you're taking away wire feed speed or whatever, but the sound is one of those things that just can't be understated here too. So just be cognizant that different transfer modes have a different sound, and that's due to the nature of how the metal is being transferred from the wire to the base metal. So the spray arc mode of transfer is by means of very small droplets of the fused electrode wire, none of which exceed the diameter of the wire in size. Successful spray arc transfer requires argon or an argon-rich shielding gas mixture. Carbon dioxide, once again, is not going to get you to the spray arc happy land. You just can't get there from here. And high current values. The results are high heat input, maximum penetration, and a high deposition rate. The arc force propels the droplets to the metal. Remember with globular, you're waiting for gravity to do the work? Not here. In this instance, the arc force propels the droplets to the metal. The puddle is larger and more fluid, which means a relatively large weld puddle is a characteristic of this mode of transfer, which limits the use of this mode of transfer to flat position groove welds and flat and horizontal fillet welds. The high current density results in deeper penetration. The high current also results in high deposition rates. Process results in a hissing or whispering sound. And I didn't really touch on that too much, but each one of these processes, and we're going to touch on pulse spray transfer, all four of the gas metal arc welding processes have a completely different sound. It's hard to explain until you've been around it, but good welders can set their welding machines utilizing the sound. I've helped guys set their welding machines, and I can hear them welding, and I can tweak it because I know what it's supposed to sound like. So you're adding voltage or you're taking away wire feed speed or whatever, but the sound is one of those things that just can't be understated here too. So just be cognizant that different transfer modes have a different sound, and that's due to the nature of how the metal is being transferred from the wire to the base metal. So let's have a little short talk here about pulse spray transfer without getting too crazy into it. Pulse spray transfer, you're just taking the spray transfer mode and you're alternating the amperage, the current, the heat, the fire, the thermal energy that is causing the weld pool, the steel, the base material or the weld metal to be melted. You're alternating that amount of energy. So the current alternates from your desired welding current to a background current. So you're heating it up real hot and then you're cooling it down or making it less hot, I guess. And this allows your puddle, your weld pool, to semi-solidify, but you're not pumping thermal energy, electricity, current into your weld puddle at a constant rate. So this gives you the ability to do some things with your waveform that you wouldn't be able to do if you just had a constant quantity of current going into your weld puddle. The background current just maintains the arc, and the peak current time and all of that is adjustable, and there's multiple waveforms. If you go to Lincoln Electric, Miller, and anybody else that's making these spray machines, these GMAW pulse spray machines, they've got waveforms that'll do all kinds of craziness. So the advantages of this are better control of the welding parameters. You can do out of position welding that you can't really do with spray transfer, and you can weld on thin metal because thinner materials, because you're not just pumping a lot of heat into it. So it gives you the advantages of the spray transfer, but it gives you the ability to run out of position and to really control your waveform and do some different things that you can't do with just spray transfer. Cold lap can occur when we use the short arc, gas metal arc welding short arc mode of transfer. Cold lap is a type of weld defect which occurs when molten metal does not completely fuse with the base material surface. This is also known as lack of fusion. So it won't show up on an X-ray a lot of the time, most of the time. So that's why when you're going to use welder qualification, when you're going to do welder qualification, you can't use X-ray when you're qualifying your welders and you're doing the short circuiting mode, because they can put in a beautiful weld, but it doesn't tie into the base metal, and it'll just snap. Your bend test will just snap right on that fusion line, or you'll have a lot of cracks open up. So that's why they don't allow the use of X-ray radiography when they're use of radiography when you're doing welder qualification. All right, let's have a short conversation today about GMAW, gas metal arc welding. Okay, so in gas metal arc welding, we've got four transfer modes. First, we got the low voltage, the low current, the low power, the low heat input, GMAW short arc. It's the lowest power input into the metal, into the weld joint. The quantity of thermal energy going in there is the lowest. That's why this one has a big red flag to me. Anytime I see this on I'm going to try and draw a little red flag here. Red flag. Anytime you see GMAW short arc on a procedure, anywhere, it should be a red flag. It's it's prone to incomplete fusion, lack of fusion. I've seen bend tests where, you know, the weld looks absolutely wonderful, and then they'll do a bend test on it. You know, you tested a welder. This was earlier on in my career, and it would just snap. It would be like snapping a twig. When it would go through the fixture, it wouldn't bend, and you wouldn't end up with a horseshoe. It would just snap. You'd have two pieces because it didn't tie in. So this is why the codes, AWS D1.1 specifically, you can use GMAW short circuiting, short arc, in a weld procedure, but you cannot use it in a pre-qualified weld procedure. And if you're going to use it, you need to understand what you're doing and have proficient welders and really qualify the procedure. One of the things where I used to review weld procedures a lot of the times, spent a couple of years in a cube up in Kansas City working for an outfit, a big construction engineering outfit, reviewing weld procedures. And I'd get, people would come through and they would come through and say, hey, this weld procedure, it's a spray procedure. Well, when you're using the transfer modes, the four different transfer modes, there's a couple of different things that come into play. The amount of voltage / current. I'm not going to get into a big argument on that. But basically, GMAW short arc is, I want to say somewhere, but depending on the size of the wire, let's call it 15 to 20.5. Once again, I'm not going to pick the fly feces out of the pepper on this one. More or less, that's what we're looking at. 20. So 15 volts to 20.5. That's generally what I'd look for. Another factor that goes into play here with short arc or with spray, you can't get into spray with 100% CO2. It's not going to get there. CO2 will not get you spray transfer. Argon will. But to do that, and once again, if you're an expert at this, I don't want to argue with you, but 75-25 will not get you into the spray transfer mode. You need at least 80% argon for spray transfer to work, minimum. Some people say 78, maybe it's 82, but I shoot for about 80. I've read somewhere in the literature, I think you could make a strong argument that 80% is kind of that cutoff zone, plus or minus 1 or 2%. But 75-25 CO2 is not going to get you into spray transfer. So I would review these weld procedures and see where people had, they'd put spray transfer, and then they'd have, 75-25. 75-25 CO2 argon. Well, you're not getting into spray transfer. So you're either doing that or you're globular. And you need to watch this when you're dealing with weld procedures and welders, because unless you know what you're listening, a lot of this stuff with gas metal arc welding is sound related. The different arc methods, each one of them has a very distinct sound to them. Pulse sounds like a buzzing bee. Spray transfer just is kind of almost a hum, I guess. Globular just sounds nasty. And then to me, short arc sounds like frying bacon. Each one has a very distinct sound to it. And when you're out walking the shop, if you're a weld inspector or an engineer and you hear something, it's like, I've walked by welders who were supposed to be using spray transfer, and they're using gas metal arc welding short arc. I could hear it. It's like, no, we don't have a weld procedure for that transfer method. Why are you doing that? Also, another thing you'll notice, this is the only one really that you can run out of position. It's good for sheet metal going uphill, horizontal, whatever. The other ones, pulse, you can sort of run out of position, and I'm not a real expert on it, but you can kind of run this stuff out of position. But spray transfer, it's pretty hot. You're going to run it in a flat position, maybe some horizontal, but you're not, for the most part, you're not running it uphill or overhead or out of position. You're just pushing too much wire and it's not freezing fast enough. GMAW short circuiting, it'll do that. You can run it out of position and run it in different situations, and it's not going to ding you too bad. Anyways, I just kind of wanted to touch base on that. But you start getting into this and dealing with welders. A lot of times if they think you're the engineer and you don't have a clue, they might run, oh well, I'll just do this weld. I got to do this weld. It's out of position. I'm just going to run it in there with GMAW short arc. We'll turn the wire feed speed and the voltage and the amperage or the voltage way down, and then I'll run this out of position. We don't have to flip it. Nobody's going to know. Well, no, it doesn't work like that. So sometimes you got to keep an eye on these things. And as an engineer or an inspector, you need to be cognizant that there is these 4 separate transfer modes for gas metal arc welding. And like I said, the amount of electricity going into it is going to be a big one. That's going to affect it. Anything above, like I said, 20.5, you're going to get into globular. And then, this is I'm using 0.45 as an example. And then, I want to say 24 to and above, 24.5 and above is probably getting out of globular and getting into the spray arc mode. And this is going to, the larger the wire you're going to use, the, of course, the voltage and the amount of current going in there is going to change a little bit. But for the most part, anyways, I just wanted to have a little chat. This has been on my mind. I got an email and had a conversation with a gentleman who was a CWI, and he had some questions about this and a couple other subjects. So anyways, I was just making a little short video to kind of explain it, and maybe this helps somebody out there in regards to understanding the 4 different transfer modes and some of the factors and variables that affect what transfer mode you're in when you're using gas metal arc welding. GMAW has 4 distinct transfer modes. That's the basis of this little summary here. Short circuiting's the lowest, usually using smaller wire diameters. You can use CO2 with it. and you use lower voltages. Globular transfer we don't use too much. It's pretty messy, but it's a higher current. It uses a higher current than the short circuiting. And if we have at least 80% argon in our shielding gas, we can use spray transfer or pulse spray transfer. And you need to understand these if you're going to be out walking the shop floor and dealing with gas metal arc welding in any significant, periods of time, if you're going to be looking at welds and whatnot, and or reviewing weld procedures.